So, good morning to the Dutchies, good evening to the other people. I think I saw Katie had like a very dark background. Whichever time zone you're hailing from, whichever part of the world, it's awesome that you're here today. Second HashiTalks. I remember when we talked about this in 2018. It's amazing. So many people and a YouTube live stream. It's great. So as Eric said, my name is Kareem Satili. Only been a Dutchman for close to 2 years. But I've been working in operations and automation for the past decade. And I'm a fan of complex systems. Usually that involves humans. And I enjoy systems that work well. And I particularly enjoy the challenge of getting there. So I'm also one of the organizers of the Amsterdam HashiCorp User Group. And since, is it 2015? I've been making my life easier with Terraform, but I still vividly remember the Wild West days of HCL 1.0 and passing providers to modules in creative ways that would never pass Terra test or any other testing tool. So if you want to talk to me about HCL 2.0, Asian whiskey, or baking cakes, you can find me on Twitter, GitHub, and LinkedIn as K Satili. Yeah. Social media, always get a shout out. Make sure to subscribe to Nick's channel, very important. And with that being said, let's move on. So I'm gonna talk a little bit about the basics. We'll touch a couple of tools, but we'll start with the most basic one, Terraform, infrastructure as code application that enables operators to create and maintain components predictably, infrastructure components, which we all know. And so let's talk a bit about how this works. So we've got providers that support a variety of services. Essentially, a provider is responsible for understanding API interactions and exposing those resources to Terraform. So you don't have to worry about how do I interface with AWS, how do I interface with Google. Provider just abstracts that for you. And you've got roughly 125 official providers. We talked about AWS, GCP, there's New Relic, Datadog, tons of other platforms. And then there's another 160 community maintained providers. We've got 1Password, a couple for Jira, for whatever reason, if you want to make your life really hard. Telegram, there's everything you can imagine. For today's session, we're going to talk about one very specific provider, which is the GitHub Provider. And I'm going to show you how to manage your GitHub organization, including teams, memberships, repositories, all with a few lines of code. So this talk draws from my experiences managing roughly half a dozen GitHub organizations with a few dozen teams and nearly 500 something repositories. So I'm hoping to show you what best practices I learned along the way. Before we start, I recently rewrote all of our code for this in HCL 2.0. So you'll need Terraform 0.12 or newer. And if you actually update to 0.12.20, you get to try some really cool new features that we'll talk about later in the Q&A. So with that out of the way, let's start by getting the information to set up our provider. Super straightforward, is you only need 2 bits of information, GitHub organization identifier, and a personal access token. And because I'm a very good automation engineer, I'm lazy, and I'll refer to this as the path going forward. So, well, the path is optional for the provider itself. You can manage organizations, you can manage individual accounts. All the examples I'm showing you today either create, read, or update GitHub resources. And so authorization in the form of a path is required by the GitHub API. And just give me a second because Zoom keeps things. Awesome. Everyone can see the slides, which is good. So Before we can dive into Terraform code, let's briefly walk through the process of creating a new path. You'll note in the slide, it's definitely not behind me, it's somewhere on your screen, that I did not grant the lead repo scope. Now, without this, Terraform cannot manage the full lifecycle of a repository, from creation to deletion. I think Omer mentioned we always want to test the Terraform plan, apply, destroy. And frequent resource recreation is absolutely typical in a Terraform managed lifecycle of a cloud resource. Within VCS, however, this approach makes less sense and can be time intensive and frankly super annoying to recover from. And let's be honest, we like our lives to be simple. So therefore, not granting the delete repo scope acts as a useful failsafe, rendering Terraform unable to remove a repository accidentally and terminating an apply run before the damage is done. So I'm seeing that some people see the slides, some don't. I'm just going to go with the idea that most people see them, and otherwise the slides will be up later. We'll figure this out. Can also just enjoy the sound of my beautiful voice. So let's briefly go back to the PAT. The personal access token, as the name implies, provides access. So it must be treated as a secret. I highly recommend you do not store this value in files that are intended to be version controlled. Thank you, Anton. If you have access to a Vault installation, storing and retrieving the secret through the Vault generic secret resource, for example, is an even better and much cleaner solution. I can tell you in the past years of using this provider, we've had a couple of moments where GitHub helpfully informed us that somebody committed their access token. Not a great moment. So I mentioned earlier that we need 2 bits of information. We now have access to a path, and for the GitHub organization identifier, I'll use operate happy, which is my infrastructure side hustle. Oh yeah, and for good measure, I like to add a version to my Terraform provider, because version pinning virtually guarantees that my code will keep working even when the provider changes in the future and new versions get released. It also makes it a lot easier for future maintainers to understand which version of the documentation is applicable as new features get added down the road. So we've got an organization identifier, we've got a path, which means we can initialize our provider. Quick Terraform init, and we're ready to go. So under the hood, Terraform downloads a binary for any and all providers, writes a log file, and subsequently stores both of these, or any or all of these, in the Terraform internals.terraform directory. Now, given that providers can be quite large, the GitHub one, for example, weighs in at, I believe, 2930 megs, it is a great idea to omit this directory from version control, even if you have Git LFS. If you want to double check that everything is okay, issue a Terraform versions command, and in your CLI, you'll see a list of all the providers in their respective versions. In this sample, we're just using the GitHub provider, but more commonly, you'll use at least the GitHub provider, the template provider, hopefully the Vault provider, and some other things. So today is a super exciting day. It's HashiTalks, we've got a YouTube stream, and my friend Igor agreed to be a reviewer for all my Terraform modules. He's super diligent about finding things worth improving in my pull requests, down to the level where you find double spaces that you didn't think were there. So let's go ahead and add him to our organization on GitHub. We'll start out with the GitHub membership resource, and I'll specify my friend's username as well as their access role. For now, I'll make him simply a member. And before going on, let's score some bonus points with everyone and run Terraform format to clean up our code. Because we all know properly formatted code is happy code after all. Terraform apply and GitHub will send an invitation to my friend and wait for them to accept. And of course, as all these interactions run via the GitHub API, any organizational settings, for example, mandated two-factor authentication, will also apply to this invitation. And any people you invite to your organization that do not have two-factor authentication enabled will simply not be able to join. Now, while we wait for my friend to accept, let's create a new team for reviewers. Kind of hoping to convince a few more people to help out, so having a full team for them makes sense. Because this allows me to set permissions on a group level rather than on individual users. And that makes security officers happy. Also makes me happy because it means less typing. So I'm naming this group reviewers. So in any future pull request, I can just use add notation in the GitHub desktop CLI, GitHub desktop application in the GitHub CLI or on github.com to ask all team members for their feedback. Now, we've invited a user, or hopefully 24 to this organization, and they've all accepted. We've created a team. So let's combine the two and add some users to the review team. For this, we'll use a GitHub team membership resource. And because this isn't Terraform 101, let's make this a tiny bit more interesting. So in this example, I'm iterating over the reviewers team variable. And don't worry about the code. I've got code samples available for everyone later. You can grab your copy on your way out. So list of GitHub users that I would like to add to the reviewers team. And by using count, I spare myself the hassle of writing out separate GitHub team membership stubs for each team member. This is the exact same way you would do this in AWS, GCP, or any other Terraform resource. All your previously garnered knowledge still applies here. So another Terraform apply, and my squad of reviewers is ready to go. Cool. Now, managing team structure is super exciting if you're into IAM and judging who gets access to stuff and who doesn't. But realistically, the beating heart of GitHub are simply repositories. So let me show you how you can manage those with Terraform using the GitHub repository resource. Think over the past 3 years, this resource has become the single most used Terraform resource in the code bases that I've worked on, to the point where pretty much all organizations that used the GitHub Provider actually ended up creating specific modules for their internal and external repositories. And with good reason too. With just 3 lines of HTML, you can create a new Git repository. And I apologize for the background noise. My neighbors apparently just decided to go drilling the wall right next to me. But we're gonna continue on. 3 lines of code. And if you're looking at the shared screen right now, the only thing that's actually needed here is the name attribute. So GitHub repositories for your code expressed as code. I think that's beautiful. So no more wondering if Joanne set up the repository the same way Samuel did, and no more, whoops, this repository was public when it shouldn't have been. Happy security officer means a happy engineer. Everyone wins. So 3 lines of code at a minimum. I think that's amazingly simple. Though if you're like me, you probably will want to change most of the roughly 20 attributes. Like, for example, the has prefix items. Using these, we can easily enable and disable additional features for this repository. In my case, we do not need a wiki. We do not need the deprecated downloads tab because we use an external registry for that. But we'll keep the issues functionality because obviously we want feature requests to come in. So on top of those features, the nitty-gritty is really figuring out what merging strategy works for you. For us, we like a clean Git history. So the only strategy we enable is a squash merging, which you can set through the aptly named allow squash merge key. You can go wild in branches, and when my PR gets merged into master, there will be a single new entry in the history. Using the auto init key, I could instruct Terraform to automatically create a README document, as well as an ignores file. And while this can be useful, it also means that a first commit to the repository will be made. And the pad owner would then become the author of this commit. Now, there's upsides and downsides to this. And if you're considering going down this route, you might be interested in creating a template repository and basing new GitHub repositories off of that template. I think this is way cleaner because you'll ensure that all your modules in this case are based off of the same template. So to make our repositories more discoverable on our team's GitHub installation, no matter if that's github.com or an on-premise one, I've added 2 topics, namely application and monitoring. As this is a list, we could also populate it through more dynamic means, such as key values for from console. And this would allow for tag reuse from the code base, so that is topics in a GitHub repository, to the final application, such as tags in a cloud provider's resource listing. And it also gives you a beautiful opportunity to build upon the work Arturo and Frederick shared in the previous session. So ever so often, you find yourself in a situation where a GitHub repository needs to be renamed. And James, yes, you can absolutely do most of this for the Bitbucket provider as well. It makes sense that when you have a couple of GitHub repositories, for whatever reason, a team name changes. Startups like to do that a lot. Repository name has to change. And you would want to do this via Terraform, right? Like, we love Terraform, let's do it in there. So there's a little caveat though. When you rename a resource in Terraform, Terraform is absolutely able to handle that for you. In fact, it will recreate the repository in question, no problem. So to be extra clear, recreating a repository means first deleting it and then creating it again. And in the output, Terraform helpfully warns us that the repository must be replaced, which is a very beautiful way of saying you're going to have a talk with half your team. And then Terraform warns you again that the renaming of the resource is a reason a replacement has to occur. So while recreation of a repository isn't a huge deal when you haven't pushed any code, which is about the first 3 minutes of a repository's lifecycle, it can be tricky when you have repository resources, such as issues and labels that aren't managed in Terraform, as yet data cannot be restored through a Git push and would therefore be lost. For me and for the teams I've worked on, this was detrimental enough that we simply do not grant the delete repo scope to a path. So you might be wondering, how do we go about this then? So to rename a GitHub repository in Terraform, we first rename the repository through the web UI, and then we alter the Terraform state using the staterm command. Fairly simple. Staterm allows you to modify Terraform state. In this case, we're removing a resource called monitoring app, and the resource type for this is the GitHub repository. And finally, once we've done that, we re-import the repository into our state file using the Terraform import command. And of course, this command can also be used to bring your already existing repositories into Terraform. And I think somebody on the chat mentioned that importing a lot of content into Terraform this way isn't a great way. I absolutely agree. Happy to talk about this later in the chat. Because yeah, you would repeat yourself many, many times to import your repositories into your state file and then create the Terraform resource definitions to match. So GitHub organizations provide various access levels, allowing you to give organization members access to reading, writing, or administrative options. Often, you have a small pool of users with full access, while still empowering team members to make choices that make sense for their team's repositories. So this is where the GitHub team repository resource comes in. While similar in name to actual repositories, these are not standalone repository resources. Here, I'm creating a relationship between the reviews team, which we created earlier, and the repository of the monitoring app. Note that both team ID and repository are dynamic references. So if the upstream changes, I won't necessarily need to update this resource too. So for now, I'm giving the team write access by setting their permissions to push. In other situations, for example, if I want to empower this team to make their own administrative choices, I could give them full repository control by setting the permission to admin. Or you could work with the newly added functionality of triaging. So now that we've created a repository and linked the team to it, let's go one step further. GitHub's branch protection feature, when configured properly, helps you write better code. In Terraform, you use the GitHub branch protection resource for this. So in the example I'm showing, we're setting up a branch protection for the master branch of the monitoring app repository. Branch identifier can be anything that includes wildcards, making it super easy to target all branches or groups of branches using a single rule. And in the updated example, you can see that I'm actually doing this, targeting anything with a prefix of release. So the teams I work on treat all commits the same. So we can set the enforce admin keys to true. What this does is ensure that all rules and protections are applied to organization admins the exact same way they apply to any other team member who commits code. Likewise, we want all commits to be signed, and we can require this using the require signed commits key. So with the basic protection taken care of, let's have a look at some more options. We can enable status checks, for example. In our case, we use an internal application called Enforcer that runs several checks on every pull request. And only when those checks pass will the branch merging screen show that beautiful green checkbox and allow for merging. So on the human side of things, we set up code reviews in a way that they get dismissed whenever new commit is pushed. This ensures that review feedback actually is worked into a pull request while not introducing new deficits at the same time. And for particular emergencies, for particular situations like emergencies, as Omar mentioned in his session, we specify that the internal team can dismiss review requirements and bypass them. Now, as teams get bigger, it is often hard to keep track of what everyone is doing. And for us, we find that inviting more people to review helps tremendously in creating a shared understanding. So rather than require a single reviewer, we prefer to have roughly half the team look at it. So using a required approving review count attribute in some of Terraform's mathematical functions, we calculate the length of the reviewers team. And indeed, it's the same team we created earlier. And then we return the closest whole number. Now, if I manage to convince 20 more people to join my group of reviewers, at least 9 of them will be required to sign off for every review. And so we have a beautifully managed GitHub organization, completely defined as code. So we've got, I think, like 2 minutes left. Let's take some time to review what we learned today. We started out by talking a bit about Terraform and created personal access token. After that, we set up our provider. We added users to our organization, created a team of reviewers. And next, we added users to the team. And I explained how to add users using a variable to save some typing. Finally, we looked at repositories. We learned how to rename them. And I showed you how to enable and disable specific features. We saw how to give teams elevated rights for their repositories. And we explored how to protect specific branches and make PRs even better by enforcing workflows that make sense for your team. Now, if you would like to try things I showed you today with your GitHub organization, take a note of the link that's shown, or go to the discussed topic that Katie has posted earlier. There you'll find code samples and further reading material that I think is super helpful to review. And if you head on over to Speaker Deck, you'll find a copy of these slides. My name is Kareem Steerley, and it has been a pleasure to talk to you today. I apologize for the background noise. What questions can I answer in the next 30 seconds? All right, so let's see. Michael, Terraform does not create branches in a GitHub repo other than the master branch. So if you use the auto init feature, you will actually get a branch because of the way the function works. So Shantanu, would it be worthwhile to mention that this was done with a commercial edition of GitHub? Actually, what I'm using for this is github.com, because most of the companies I've worked with want to onboard developers quickly, and they just give everyone access to their GitHub organization. You can absolutely do this with a commercial edition, but you don't need to. And is it possible to use organization-wide access tokens? I believe it is, but I haven't tested it this way. And for what it's worth, in terms of auditing, it's great to see which user created repositories or access permissions. So I would actually recommend against that. Thank you for clarifying, Chantal. You can also use this with the free organizations. So as long as you don't have any private repositories, all of this code will completely work. And I think that's all the time we have for today.